Hello, algebra students, advanced algebra that is. Welcome back to another video lesson as we continue to look at nth root power functions and really kind of trying to understand how to solve and simplify them. We'll get more into a little bit of their behaviors and properties next week, but today we really want to focus on evaluating them and finding those real solutions. And so yesterday and today is all about kind of evaluating them when we have them to the power of 1/3, 1/4, the nth root, if you will, where we're going to be solving some as well. So I got a couple of warm-up questions I want you to try and answer. How many real solutions does the following equation have? X to the 5th equals 30th. That would have one real solution. It's an odd power, and because it's an odd power, it is only going to have one real solution. Okay? Odd powers have one real solutions. Letter B. What is or are the real solutions to this one? X to the 4th equals 16. Well, this would be plus or minus 2. 2 times 2 times 2 times 2, or negative 2 times negative 2 times negative 2 times negative 2 would give us that 16. Because it's an even powered, we will possibly have two real solutions. And then the last two are more solving as well, simplifying, a little bit different when we talk about simplifying, but 25 to the 1/2 or 16 to the 1/4. We could do this on a calculator if we needed to, but 25 to the 1/2 is the same as saying the square root of 25, which is 5, right? When we simplify, we're just going to get that 1. 16 to the 1/4 is the same as saying the 4th root of 16. So, x times x times x times x is 16. We just did that up here in letter B, and that is 2. So 2. And now what we need to try and understand is there's a difference here between simplifying, finding all the roots, and solving. When we are simplifying, we're really just looking for the positive roots, the positive answers. And again, 36 to the 1/2 is the same as saying the square root of 36, which is 6. And again, if we're simplifying, we're only looking for that positive value. Finding all the roots is like finding all of the intercepts, the solutions. And so these two are very similar. Find all the second roots. So again, that's the square root of 36, some number times itself. And when we have that, when we're finding the roots, we do want plus or minus 6. Same thing if we're solving, right? We take the square root of both sides to show that x could equal plus or minus 6. And so anytime we're simplifying, we're typically going to have just one answer. But if we're finding roots or solving, we may have two answers if it's an even root that we're looking for. Second root, fourth root, sixth root, things of that nature, because then there will be two of them, as we talked about from a graphing standpoint, and finding those x-intercepts. Now that leads me to this slide where we're going to try and graph the scenario here. Okay, x to the 3rd equals negative 27. If we try and graph 2 on the same graph, y equals x to the 3rd, it's a positive and odd, and so we learned earlier in one of our chapters that it looks like a graph, something like this. And then if we graph the other side, y equals negative 27, that's going to be a line crossing the y-axis way down here at negative 27. And so it will have one possible answer way down here in the 3rd quadrant. Right down there in that 3rd quadrant. In this case, it's probably negative 3. Whereas when we look at x squared, again, we have a positive even, meaning it goes both directions. And then we're looking for where does y equal 16. And so we draw that y equals 16 line, and you'd notice we would get two real answers, at 4 and at -4. Okay, and so that's really what's happening when we think about these graphs of these and trying to understand if we have one solution or two solutions. Odd powers are only going to have one. Even powers are going to potentially have two. Now, as we look at solving these, and I went through this a little bit quicker on yesterday's video, more of an introduction, but as we're trying to solve, the goal is to still isolate x to the power of whatever value, n, we'll call it some number. Right? We want to isolate that because to undo the n, to undo the power, we take both sides to the power of 1 over n, the reciprocal, basically. Right? When we do that to both sides, and let me discuss why. We're going to use this example, right? X to the 5th. If I'm trying to get x by itself, right? If I'm trying to get just x, this x has a power of 1. So if I raise this to the reciprocal, which is 1/5, the property and rule here for a power to a power is that I would be multiplying those. 5 times 1/5, which is 1, meaning I do get x to the 1st. Okay, so if I look at this example, x to the 5th equals 32, that means to get x to the 1st, to get x by itself, I raise it to the 1/5 power, but the golden rule in math is whatever I do to one side, I have to do to the other, or 32 to the 1/5. So if I'm trying to then solve, right, what is 32 to the 1/5, that's asking me what number times itself 5 times is 32. Right? That's the same as looking for this 5th root of 32. So I'm just going to guess and check, like 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. If it wasn't 2, I'd start with the number 3 and look at, well, what do I get for 3? Okay, and again, we're solving, but I have an odd power, and so we're only going to get one real answer. Over here in our second example, if I've got x to the 1/3 power, to get x by itself, I raise it to the power of its reciprocal, raise it to the power of 3, which means I have to do that on the other side. And 5 to the 3rd is 5 times 5 times 5, or x equals 125. Okay, and so the opposite of raising something to a power is raising that again to its reciprocal power. All right, let's try and put those into practice with a couple of examples. Simplify each of these 4 without a calculator. Why don't you pause the video here and see what you get, maybe in terms of at least setting these up and trying to solve. Okay, 64 to the 1/3 power. Again, we're simplifying. That's like saying the cubic root of 64. So some number x times x times x. Well, if I use 2, 2 times 2 is 4, times 2 is 8. Check 3. 3 times 3 is 9, times 3 is 27. Check number 4. 4 times 4 is 16, times 4 is 64. So the answer here would be 4. 36 to the 1/2 power. It's like saying the square root of 36, and hopefully you know the square root of 36, some number times itself, is 6. And again, it's only asking us to simplify, so I'm only looking for that one positive root. 10,000 to the 1/4. That's like looking for the 4th root of 10,000. Okay, so x times x times x times x. 4 of them. If I know that it has a bunch of zeros in it, though, it's probably going to be 10. 10 times 10 is 100, times another 10 is 1,000, times another 10 is 10,000. And the last one, 1600ths, 0.16 to the 1/2, is like taking the square root of 0.16. And hopefully you might be able to see that that's the decimal point for 0.4 times 0.4 is that 0.16 or 1600ths. Okay, and so simplifying, you should be able to do a lot of that, what I will call mentally, without a calculator. Now, how do we use this information to help us solve? Well, again, the goal is to isolate the x to the power. So I'm going to add 16 to both sides, meaning 2x to the fourth equals 32. And then if I divide by 2, I get x to the fourth equals 16. So to undo that, we raise it to the power of 1/4, both sides to the power of 1/4. Or x will equal 16 to the 1/4 is like looking for the fourth root of 16. 2, 4, 8, 16, so it would be 2. But because it's an even root and it's a positive number, we could have both positive or negative 2 as an answer. Okay, the even root. Why don't you try the next one? See what you get for this one. First step is to divide by 5 so that you can isolate the x value. X to the 1/5 power equals 2. To undo raising something to the fifth, we raise it to its reciprocal, or 5. I've got to do that to both sides. And 2 to the 5th power, 2, 4, 8, 16, 32. X would equal 32. All right, so again, just some more examples on how to set up some of those solving ones. Here's 4 more examples where you're trying to solve and finding the real solutions without a calculator. I want you to pause the video here and try all 4 of those. When you get back, I will have work and answer here on the screen. Good luck. All right, I hope you took some time to try and solve those. In letter A, we divide both sides by 4. X to the 1/2 equals 9, so we square that, and 9 squared is 81. In letter B, we subtract 27 from both sides, so we're left with c to the 3rd equals 3. We take each side to the 3rd power, and 3 to the 3rd is 27. In letter C, we have x to the 4th, so we raise it to the 1/4 power. So we do that to the other side, meaning the 4th root of 256, so some number times itself, and that's 4, but because we have an even power, we could have positive or negative 4 for an answer. And in letter D, we've got x to the 3rd, meaning we raise it to the 1/3 power, meaning we're looking for the cubic root of negative 125, so some number times itself 3 times, which would be negative 5. So I hope you found those examples helpful. You got a lot more practice on that today. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.